So okay students, so now we will start our example for the LU decomposition, and example number 1 is solved by Crout's method. Okay, so as you know that in the Crout's method we replace the upper diagonals as 1, and then we solve the system by four steps or step 4. And the question is, it is basically a 3 cross 3 system, and that is 3x plus 1 plus x2 minus equals to minus 1, and 2x1 plus 4x square plus x3 equals to 7, also 2x2 plus 5x3 equals to 9. So this is a 3 cross 3 system, and we will start solving it by Crout's method. So we write the coefficient matrix. The coefficient matrix is 3, 1, 0, 2, 4, 1, 0, 2, 5. And if we write if we relate it in with the Crout's method, then this is the lower diagonal matrix, that is L11, L22, L33, and these upper entries are 0. So this one is L21, L31, and L32. Multiply by upper entries are 1, 1, 1, and these lower entries are 0, and here it is U12, U13, and U23. Now we solve it by multiplying this right hand side to the left hand side by comparing its unknowns and the coefficients. So if I select this A11, we take if we have basically 9 entries in this coefficient matrix, so it develops 9 different equations to solve the unknowns, to find out the unknowns. So basically, if it is A11, that means it is for row, and that second is for column. So that means row of this lower matrix and column of the upper triangular matrix. So we can compare the coefficients, 9 equations. So first is A11 is 3, and 1 means first row of this lower matrix and first column of this upper triangular matrix. So it contains this element like L11 into 1. So if I write is L11 into 1 plus 0 into 0, as you know the matrix multiplication, plus 0 into 0, so that develops L11 equals to 3. So this makes equation number 1. Also, if we have A12, then A12 the element is 1, so that means first equation and row and second column. So that develops L11 into U12 plus 0 multiplied by 1 plus 0 multiplied by 0. So that develops 1 equals to, if I replace the value of L11, that is 3, so U12 is equal to 1 by 3. So that is the second equation. So we solve it like this. So first row and third columns, L11 0 0 and U13 U23 and 1. So the element here is 0. So that makes it L11 into U13 plus 0 into U23 plus 0 into 1. So that makes it 0. Okay. So if I replace the value of L11, that is 3, so U13, 0 divided by 3 is U13, so that is the third equation. Okay, now we come to the second row, and that is A21, that means second row of lower and first column of upper triangular matrix. The element itself A21 is 2, so L21 multiplied by 1 I'm just writing it directly, plus L22 into 0, that makes it 0, plus 0 into 0. Okay, so L21 is equal to 2. Similarly, A22, the element is placed here is 4 and L21, and now we have the second row of lower and second column of upper. So L21 into U12 plus L22 plus 0. So we replace the value of L21, that is 2, and U12 is 2, that makes it 1 by 3 basically, so that makes it 2 by 3. So L22 is, if we 4 minus 2 by 3, that makes it 12, so that 12 minus, okay, 2, that makes it L22 is 10 by 3. So I highlight it because we have to replace these all values in this equation. Now the third one is second row and third column, so that makes it this element that is at the position A2 3. So second row and third column itself the element is 1, so L21 into U13 plus L22 into U23 plus 0. So we replace the value of L22, L21 and U13. And U13 makes it 0 because it is a 0 number here. So I replace its value and only we are left with 10 by 3, that is the value of L22 into U23. So U23 is equal to 3 by 10. Okay, so we are left with only 3 equations and 6 are determined. So A31 means third row of lower and first row of this upper triangular matrix itself. Element here is 0. So 0 equals to L31 into plus 0 into plus 0. Okay, so that is your 7th equation, and L32 is third row and second column. So itself the element here is 2. So 2 is equal to L31, okay, into U12 and plus L32. So L32, so because of L31 it makes it 0, so L32 is I guess it is 2. Okay, so the last one is A33 and that is, it's 5. Third row, third column, L31 into U13 plus L32 into U23 plus L33. So I replace the value because of the U13 and L31, these both are 0, and L32 is yes 2. So 2 into U23 is U23, where is it? 3 by 10 plus L33. So 5 equals to 6 by 10 plus L33. So 5 minus 6 by 10, that makes it, if we take it its LCM, then 50 minus 6, that makes it 46 by 10, and if I solve it further, then it becomes 23 by 5. Okay, so 23 by 5, what's the value of this? If I solve it, it may be 4.4. It may be 4.4. Okay, yes, it is 4.4. So L33 is 23 by 5. Okay, so now I replace the value of these unknowns in this equation and I erase the rest of the equation. So L11, L21, and also this U12, U13 and U23. Okay, so L11 is 3, L21 is 2, L31 is 0, and L22 is 10 by 3, L23, okay, L32 is 2 and L33 is 23 by 5. Similarly, U12 is 1 by 3, U13 is 0, and any unknown, and solve it by Ly. Step number 3, I guess that is step number 3. So Ly or Z, if I solve it by Z, it doesn't matter, whatever the unknown is, equals to B. So lower triangular matrix is 3, 0, 0, 2, 10 by 3, and 0, 0, 2, 20, 23 by 5. Okay, Z1, Z2 and Z3 equals to B. So we can here solve it by forward substitution method. That is, the equation 1 is solved by, it makes it 3Z1 equals to minus 1. So Z1 equals to minus 1 by 3, and second equation is 2Z1 plus 10 by 3. Z2 is equal to 7. So that makes it 2Z1 is it makes it minus 2 by 3 plus 10 by 3. Z2 is equal to 7. So if I solve it, then I get 10 by 3 Z2 and 7 plus 2 by 3. So if I take the LCM, 3 into 7 is 21 plus 2 by 3. So that makes it 23 by 3. And if I cancel it, then Z2 will become, Z2 is equal to 23 by 10. That makes it 2 by 2, 22 by 5. Okay, Z3 is equal to 22 by 5, and here it is 22 by 5. So if I solve it, then we get Z3 equals to 1. You can check it by your own self. Okay, so now we replace these values and we solve this U equals to Z. Okay, so I just replace these values of Z1, Z2 and Z3. That makes it step number 4. Okay, so 1 by 3, 0, 0, 1, 3 by 10 and 0, 0, 1 ux equals to into x1, x2, x3 is equal to, Z1 is minus 1 by 3, Z2 is 2.3 or 23 by 10, and Z3 is 1. So I just start solving it and we get the values of x1, x2 and x3. Okay, now so we use the backward substitution process here. So x3 here is 1 and x2 plus 3 by 10, x3 is equal to 23 by 10. So if I solve it by 20 plus 3 by 10 into x3 is 1, and if I solve it, then it becomes x2 is equal to 23 minus 3 divided by this. So that makes it this, and x2 is equal to 2. And last equation is x1 plus 1 by 3, x2 plus 0 equals to minus 1 by 3. So if I replace the value of x2, that is 2 by 3 minus 1 by 3. So x1 equals to minus 1 by 3 minus 2 by 3. That is minus 3 by 3. So x1 is minus 1. So this is the solution set, and that is, if I write it here, so this is the solution set, that is minus 1, 2 and plus 1. So this is the solution.